Welcome my dear students. Today my topic is chiral substrate controlled asymmetric synthesis and application of Cram's rule wherever it is possible. Now let us begin with the chiral substrate which can give rise to the diastereomers. So the question is, during these reactions one diastereomer will be major over the other. Our substrate in this topic is compulsory a chiral substrate, and not only that, adjacent to that chiral center we have some diastereotopic faces, otherwise the diastereotopic ligands. And when we design all these asymmetric synthesis, then the reagents which are used for such type of reactions, specifically they target those diastereotopic ligands or the diastereotopic faces present in those chiral substrates. And due to the facial biasness or some steric crowding, one particular reaction happens easily, so that leads to the major diastereomer. Now coming to one simple example where we have taken one chiral substrate where the chiral center contains the 4 different groups. One is C double bond O and the remaining 3 are X, Y, Z. Now when we will take this substrate, we have to take a particular enantiomer, means either we want to take R, otherwise we have to take the S. Racemic mixture is not allowed to do. Now adjacent to this chiral center we have C double bond O, and the topic relationship between these two faces of C double bond O are diastereotopic. Now if we plan some reactions targeting this C double bond O like nucleophilic addition, otherwise reduction, then because of that reaction we will get one more new chiral center in the product. I mean we will be having two adjacent chiral centers in the product, and which which the diastereomer will predominate. It will be exclusively determined by the chiral center which is present in the substrate, and as because next to this chiral center only we are getting a new chiral center, that's why this method is called as the 1-2 asymmetric induction. Now coming to application of Cram's rule in order to identify the major diastereomer and the minor diastereomer, we have to follow certain steps without any mistake. First of all, we have to go to the chiral center and the 3 groups other than the C double bond O, we have to identify based on their size which one is a large group, which one is the medium sized group, and which one is the small group. Now the molecule we have to write into the Newman projection style, projecting the C double bond O and the chiral center so that C double bond O and the large group of the chiral center will be anti. In that case, the C double bond O will be in between medium size group and the small size group. Now according to Cram's rule, the reagent will approach to the small size group to the C double bond O will give the major product, and if the reagent approaches from the medium size group, then that will lead to the formation of the minor diastereomer of this 1-2 asymmetric induction. Now coming to the few variations of the groups which are present at the chiral center, let us first consider that if the chiral center adjacent to the C double bond O contains the halogen, in that case we have to apply Cram's dipolar model. Means according to Crams, in this case, means if the chiral center adjacent to the C double bond O contains halogen, then irrespective of the size of halogen, we have to place halogen anti with respect to C double bond O, and after that C double bond O, if it is in between the two groups, from those two groups which is small, the reagent will approach from that side, will lead to the major diastereomer. Now let us solve one question, that R enantiomer of 2-chloro-3-pentanone, if it is subjected to sodium borohydride reduction, then we have to identify the major and the minor products. Now, before going to the stereochemical discussion of 1-2 asymmetric induction, let us first discuss the simple chemical reaction which will happen on 2-chloro-3-pentanone. Now, 2-chloro-3-pentanone has C double bond O, and that will be reduced to the secondary alcohol by using sodium borohydride. Now, if we start from the R enantiomer of that particular substrate, then that substrate center means that chlorine bearing center will not participate in the sodium borohydride reduction. So therefore, in the product also this chlorine bearing center will retain its stereochemistry, that is R. Now the question is, after reduction, when we will get the secondary alcohol center, that secondary alcohol center is a chiral center because it is attached with the 4 different groups. One is OH, one is ethyl, one is the chloro-bearing carbon, and another one is the hydrogen. So now the question is, this newly generated chiral center, because of 1-2 asymmetric induction, what will form? Will it form R or will it form S? Means in that case, we are going to get the 2 diastereomers. One is the RR, another one is the RS of the product. Now the question is, by applying the Crams dipolar model, because the chiral center contains the chlorine, we have to identify which one will be the major product. RR will be the major product or RS will be the major product. Now, in order to solve this problem, first on paper we have to write correctly the R enantiomer of that particular substrate in a Newman projection, maintaining the Crams rule, means the chlorine should be anti with respect to C double bond O, and in addition with that, the chiral center which is present in the substrate must be R. So for that purpose, the first thing is we have to give the priority to the chiral center. So if we give the priority to the chiral center, chlorine will be the first priority, CO will be the second priority, methyl will be the third priority, and the hydrogen will be the fourth priority. Now I have kept the reaction center, means the C double bond O at the center of the circle in the Newman projection, so that the chiral center will go to the boundary of the circle. So while writing like this, a second priority group, means C double bond O is coming in front of us, so we can apply the 2F minus rule. That is, so 2F minus rule if we want to apply and we want to get the R substrate, in that case the chlorine, methyl and the hydrogen we have to place in an anti-clockwise manner, so that that chiral center will maintain the R enantiomer. Now the thing is, in order to apply the dipolar model, chlorine compulsory should be at the bottom, means the anti with respect to C double bond O. So the chlorine is at the bottom, right hand side ki methyl, left hand side ki hydrogen. If we place, then compulsory it will come the R substrate. Now after writing this, we have to see the C double bond O is in between, one side hydrogen and another side methyl. Hydrogen is the smaller group, so therefore sodium borohydride will approach from the left hand side, means the hydrogen side will reduce the C double bond O to the secondary alcohol. So that will give the major product, and then we have to find out what is the absolute configuration of the newly generated chiral center. So now the thing is, if we want to do the RS in this Newman projection, again the newly generated center we have to give the priority. Here OH is the first priority, the second priority is which is at the back side, means the chlorine bearing carbon, ethyl is the third priority and the hydrogen is the fourth priority. The group which is at the back, means the second priority group is at the back, so therefore we can apply the 2B plus. Now OH is first priority, then ethyl is the third priority and the hydrogen is the fourth priority. So 1, 2, 3, 2, 4, it is moving in the clockwise direction. In this situation, if we apply the 2B plus, then definitely we will be getting the R. Already the old center coming from the substrate, it was R, newly generated center is also R. So by applying dipolar model, we have predicted that in this reaction R enantiomer of the substrate on sodium borohydride reduction will produce the R diastereomer as a major product, and therefore the minor product will be having RS absolute configuration. The R is the chlorine bearing center and the S is the OH bearing center. Now if we write in a reverse way, the R enantiomer of the substrate can also be written in a reverse way. I want to mean that C double bond O in the boundary and the chiral center at the center. In that case also, by applying all these rules, we will be getting the RR as a major product. And now one important aspect of this question is the R enantiomer of the reaction on sodium borohydride. If it produces the R enantiomer as a major product, if we start from S enantiomer of the substrate, which product we will be getting? The answer is SS enantiomer will be the major and the SR enantiomer will be the minor product if we start from the S enantiomer of the above substrate. Now coming to the other variation of this Cram's rule, if the chiral center contains the oxygen or the nitrogen containing group next to the C double bond O, in that case the Cram's cyclic rigid model we have to apply in order to identify the which diastereomer will be measured correctly. Now in this case, if the oxygen containing group or the nitrogen containing group, they are the medium sized group in the chiral center adjacent to the C double bond O. In that case, rigid model as well as the open model both will give the correct major product, but if the OH and the nitrogen bearing group is the large group or the small group at the chiral center next to C double bond O, in that case the cyclic rigid model and the open model, they give the two different answer, and in that case the answer which comes from the cyclic rigid model is the correct answer. Now let us apply our concept in the example that R enantiomer of one compound where we have the chiral center and next to the chiral center we have the C double bond O. The chiral center contain phenyl, methoxy and the hydrogen. Phenyl is the large group, methoxy is the medium sized group and the hydrogen is the small group. So as because the oxygen containing group is the medium sized group, so therefore cyclic model as well as open model both will give the same answer and both are correct. Now this compound was subjected to the Grignard addition by using the ethyl magnesium iodide followed by hydrolysis. Now by applying rigid cyclic model, otherwise the open model, it is observed that RR diastereomer of the final product is the major. Now let us see what is the meaning of the cyclic rigid model and how to write on paper. So the rigid model means the C double bond O oxygen and the chiral center ki heteroatom like oxygen or the nitrogen, both of them will undergo the complex formation with the metal which is present in the reagent, and in this case it is magnesium because we are using ethyl magnesium iodide as reagent. So after writing these things, we have to see the remaining two groups, means in this case the remaining two groups are hydrogen and the phenyl. So in between these two, which is the smaller group? The smaller group is the hydrogen. So the reagent means the ethyl group will come from the hydrogen bearing side, will lead to the product, but in this case the main difference is when we are applying the cyclic rigid model, in that case our final product we were getting the in staggered form, whereas in the previous case we have got it into the eclipse form. Now let us come to this, how to write the R enantiomer of the substrate and how to know after applying the Crams rigid model which absolute configuration has been created, whether it is R or S. Now coming to the substrate, it is given that we have to use the R enantiomer, and not only that, C double bond O and the OMe should be close enough. So now the thing is, we have to see that chiral center ki priority. OMe means oxygen is the first priority, C double bond O is the second priority, phenyl is the third priority, and the hydrogen is the fourth priority. Now C double bond O I have written on the boundary of the circle, so that is the second priority. So second priority group I have written on the back side, means I am going to apply the 2b plus, means if I want to get the R at the chiral center, which is at the center of the circle, I have to write the methoxyphenyl and the hydrogen in the clockwise, means the first priority, third priority and the fourth priority group, they will be in the clockwise manner, then only it will be coming R. Now in between the hydrogen and the phenyl, hydrogen which is coming in the left hand side, that from that side only Grignard reagent will approach, and we will be getting the ethyl in the left hand side, OH in the right hand side, down ki methyl. So now this center also we have to do this, what will be the absolute configuration. So for that, again in the newly generated chiral center we have to give the priority. OH is the first priority, the the methoxy bearing center which is coming from the substrate chiral center, that is the second priority, ethyl is the third priority, and the methyl is the fourth priority. So the second priority group is in front, so we have to apply the 2F minus, second priority group is front, and in that case clockwise manner will give the S and the anti-clockwise manner will give R, but we should not consider the second, means we have to see the 1, 3, 4, these three groups. So now the first priority group is OH, second priority, third priority group is the ethyl, and the fourth priority group is methyl. So oxygen to ethyl to methyl, it is anti-clockwise manner, and we have to apply the 2F minus, means the newly generated center is R. So the RR diastereomer is major, RS diastereomer will be minor. Now as because the methoxy group is the second priority group, and as I have already told you, if this oxygen or the nitrogen containing groups in the chiral center comes as a medium sized group, or the, in that case what happens na, open model and the cyclic rigid model, both of them will give the same correct answer. So we have already solved and got the RR in diastereomer as a major product. So if we apply this in the open model also, we have got the RR diastereomer as a major product over the RS diastereomer. Now coming to the next example, where in the chiral center next to the C double bond O has one phenoxy group, and which is the largest group present in the chiral center, because this, in this case the chiral center contains the OPH group, methyl group, hydrogen other than C double bond O. So OPH group has the highest bulk, means it can be considered as a large group. Methyl is the medium size group, and the hydrogen is the small size group, and this molecule is again allowed to react with the ethyl magnesium iodide followed by hydrolysis in order to get one secondary alcohol. Now the thing is, in this case, if we apply the cyclic rigid model and the open chain model, both will be giving the two different answer. The correct answer will be the based on the cyclic model, not with respect to the open model. If we apply open model, then whatever answer will come, opposite answer is the correct answer. So it is an open choice whether we can apply the cyclic model. If we are not thorough with the cyclic model, then we can apply open model, and the reverse answer we can quote as the right answer. Now R enantiomer if we draw, in that case to apply the cyclic model, phenoxy group and the C double bond O should be closest, and both of the oxygens should undergo the complex formation with the magnesium of Grignard reagent. And in addition with that, the chiral center should have the R absolute configuration. So in order to do that, the chiral center priority we have to see oxygen first priority, C double bond O second priority, methyl third priority, and the hydrogen fourth priority. Now if we write that C double bond O and the methyl on the boundary of the circle, then at the center we have to write the chiral center, and in that case we have to apply the 2b plus, means the phenoxymethyl and hydrogen we have to place in a clockwise manner in order to get the R absolute configuration at the chiral center. Now phenoxy group should be closest with the C double bond O, then leftover two groups, means the hydrogen and the methyl, we have to check. Hydrogen is the smaller group, so the reagent ethyl magnesium iodide will preferably attack from the hydrogen side, will give the measure product. So after writing the measure product in the staggered form, then we have to apply this concept in order to find out the newly generated chiral center absolute configuration. Old center is R, but the new center which is at the back side, so in that case again we have to do the priority, means the OH is the first priority, the old chiral center is the second priority, ethyl is the third priority, and the methyl is the fourth priority. Second priority group is coming forward towards the viewer, so we have to apply 2F minus, means the OH to ethyl to methyl, it is appearing anti-clockwise, means R is the measure product. And same answer will not be obtained from the open model, because the OPH group is the large group and we will be getting the RS in that case. As already I have told that if we apply the open model in that case, then reverse answer will be the final correct answer, means RS we are getting by applying open model, means RR will be the correct answer. So now in order to make the ideas comfortable, we have solved some examples. There are 4 examples are there. If you solve, then hope you will be getting the correct answer. First try on your own. If you don't get the answer, then only you see how I have solved. If you have any doubt, then you please put comment in the comment box. I will try to come back to you to clarify your doubts. Thank you very much for watching this video and investing time behind these all concepts. If you want me to make some video on certain topics, please keep comment in the comment box. I will try my level best to prepare new videos on those concepts. Once again, thank you very much.